I hope all of you are doing good. Let's start today's chapter, direct and inverse variation. Introduction. In the previous chapter, we have read about ratio and proportion and unitary method. In this chapter, we shall use the concept of proportion and unitary method in the development of the concept of variation. Let us consider certain facts of life. Number 1. More the speed of a car, less time it will take to travel the same distance. Number 2, the more our bank deposit, more interest we gain from a bank. 3, more laborers work, less number of days needed to complete the same work. These cases give rise to the concepts of direct and inverse variations. In this chapter, we introduce these concepts and use them in solving problems on time and work and on time and distance. Number 1, direct variation. If two quantities x and y vary with each other in such a manner that the ratio x by y remains constant and is positive, then we say that x and y vary directly with each other, or x and y are in direct variation. Suppose one wants to buy petrol for his vehicle. The more petrol we buy, the more we pay. Two quantities varying in this manner are said to be vary directly with each other. Consider this table. 5 liters petrol. Cost of 5 liters petrol is 200 rupees. Cost of 10 liters petrol is 600. See, petrol is increasing and cost is also increasing. Okay. So observe the table. As the values of x increase, the values of y to increase. So whenever we compare the ratios of x and y, for example, whenever we'll compare the ratios of these ratios, what do we observe? We'll get the same value, that is 1 by 40. So the ratio x by y doesn't change, and we denote this constant by the letter k. This constant is known as the constant of a variation. Let us consider some examples. Find a and b in the following table if x and y vary directly. Okay, see, x and y vary directly. So therefore, x by y should be constant and positive. So x by y is equals to 8 by 12 is equals to 2 by 3. Okay, see, x by y is equals to 8 by 12. That is, so x by y is equals to 2 by 3. Okay, so we have to find the value of a and then b. So x by y, that is 2 by 3, is equals to 14 by a. Okay, 2a is equals to 14 into 3 and a is equals to 14 into 3 by 2. So a is equals to 21. Similarly, we will find the value of b also. Okay, 2 by 3 is equals to 16 by b. So 2b is equals to 16 into 3. So b is equals to 16 into 3 by 2. So b is equals to 24. So the value of b is 24, right? Exercise 11.1. In which of the tables x and y vary directly? Okay, 3 by 4, then we have 5 by 8, 6 by 12. Okay, 5 by 8, we cannot reduce it to lowest term. 6 by 12 is 3 by 4. Okay, 7 by 13, also we cannot reduce it to lowest term. So this is not the table in which x and y vary directly. Okay, let's check out the next table. X by y is 11 by 3. Now 55 by 15. 11 by 3. Then we have 77 by 21. 7 ones are 7, 7 ones are 7, 7 threes are 21. Okay, 88 by 24. 8 ones are 8, 8 ones are 8, 8 threes are 24. Then 99 by 27, 9 ones are 9, 9 ones are 9, 9 threes are 27. And 121 by 33, 11 ones are 11, 11 ones are 11 and 3. So 11 by 3. So this table, in this table x and y varies directly, right? Similarly, you will find out whether the table varies directly or not. Okay. Next, inverse variation. We have seen that in case of direct variations, the two quantities increase or decrease together in the same ratio. However, sometimes corresponding to an increase in the first quantity, there is a decrease in the second, and when there is a decrease in the first quantity, there is a corresponding increase in the second. Let us consider some examples. Number 1, Suppose 5 persons can do a job in 6 days. Now, if more people join the group, it will take a less number of days. However, if some of them leave, then it will take more than 6 days to complete the work. 2. Suppose a car travels a certain distance, more the speed of the car, less the time taken. 3. Suppose a given mass of gas is subjected to a pressure. As the pressure increases, the volume of the gas decreases. These are all cases of inverse variation. We find that when two quantities vary inversely, an increase in one quantity leads to a decrease in the other quantity in the inverse ratio. For example, consider this table. One person will do a certain kind of work in 24 days, and if number of persons are 2, then the days required 12. Means, see, number of persons are increasing and number of days are decreasing, right? So, this is your inverse variation. Okay. So, the table depicts the number of days required for doing the job when 1, 2, 3, 4, 6, 8 and 12 persons are put on a job. Okay. So, what do we notice? We observe that the product of the corresponding values of the two quantities is constant. That is, 1 into 24 is 24, 2 into 12 is 24, 3 into 8 is 24, 4 into 6 is 24 and so on. Right? Therefore, if x and y vary inversely, then x, y is equals to k is equals to constant. Thus, we can say that two quantities x and y are said to be vary inversely if there exists a relation of the type x, y is equals to k between them, where k is a positive constant number. We note that if x1 and x2 are the corresponding values of x and y1 and y2 are the corresponding values of y, then x1 y1 is equals to x2 y2 is equals to constant. Okay. So, x1 upon x2 is equals to y2 upon y1. Okay. Example 1. In a boarding school, there are 252 students and there are provisions for 70 days. If 280 more students join the school, how many days will the provision last? Okay. So, this is a case of inverse variation. So, the relevant table is given here is, see, number of students after joining. Okay. Initially, there were 252 students and then 280. Okay, 28. This is 28. Okay. 28 more students joined. Now, the number of students 252 plus 28 is equals to 280. Okay. So, number of students 252 and provision for the number of days is 70. Then total students after joining 280 and we don't know the now how many days will the provision last. So, we will consider x. So, 252 into 70 is equals to 280 into x. Okay. 252 into 70 upon 280 is equals to x. 0, 0 goes, 7 ones are 7, 7 4s are 28. 4 6 are 24 and 4 3s are 12. So, 63 days. Okay. Answer is 63 days. Right. Problems of inverse variation involving time and work and time and distance. We shall consider some more problems on time and work and on time and distance with the concept of inverse variation. Example 1. A car can complete a journey in 12 hours at a speed of 60 km per hour. By how much should its speed be increased so that it takes only 10 hours to cover the same distance? Okay. So, this is also a case of inverse variation. So, the table is, relevant table is, see, we'll make, we'll write here number of hours and your speed in kilometer per hour. Okay. So, in 12 hours, a car completes a journey in 12 hours at the speed of 60 km per hour. Okay. By how much should its speed be increased? Okay. So, we don't know the speed if it takes 10 hours. So, how will you do it? 12 into 60 is equals to 10 into x. So, 12 into 60 upon 10 is equals to x. 72 km per hour should be the speed. Okay. But we have to find the how much should its speed be increased? Means the required increase in speed is what? 72 minus 60. 72 minus 60 is equals to 12 kilometer per hour. Right? Let's do exercise 11.2. Which of the following vary inversely for each other? Number 1. A train travels at a constant speed of 45 km per hour. What is the distance travelled by it in 4 hours? Does it vary inversely? No. Number 2. 25 men can do a piece of work in 6 days. How many men are needed to complete the work in 3 days? So this is inversely proportional. Okay. Price of wheat is rupees 12 per kg. What is the cost of 45 kg of wheat? Okay. So price of 1 kg of wheat is 12 rupees. Okay. If the quantity increases, then rate will also increases. That means this is not inversely proportional. Okay. They do not vary inversely. Right. Similarly, next example also. 1 dozen pencil cost rupees 15. That means cost of 8 such pencils we have to find out. Means cost 1 dozen means 12 pencils. Cost of 12 pencils is 15, and if the number of pencils decrease, then the cost will also automatically decrease. Okay. So this is also not inversely proportional or inverse variation. Right. Things to remember. Number 1, 2 quantities x and y are said to vary directly as each other if they increase or decrease together in such a way that x by y is equals to k, where k is a positive constant number. 2, 2 quantities x and y vary inversely as each other if an increase in x causes a proportionate decrease in y in such a way that the product of their corresponding value remains constant. Hence, if xy is equals to k, where k is a positive constant number, then x and y vary inversely. Number 3, the relation between time, distance and speed is this. Speed is equals to distance upon time. Okay students, now you will do practice of the remaining questions of the exercise.